Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Basics, Trigonometric Functions, Concept number 3, Standard Position and Cosine. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is so effective. I'm coaching you to turn your wants and desires of getting an A or perfect test score into a new paradigm. I want to include everyone who needs a boost in Algebra 2. If I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to order this complete cram session. Get your healthy dose and be sure to tell your friends, peers, classmates, and or colleagues who could also benefit from this cram session to inbox me at memedicine@gmail.com to order the complete Algebra 2 cram, okay? So be sure to spread the word to them. They'll make great study buddies. The concept of cramming often has a negative connotation, but what people are actually thinking of is hurrying, which is a result of fear rather, and can consequently be destructive. We're not hurrying, we're cramming. There's a difference. Hurrying is jam-packing tons and tons of unorganized chaos, chaotic information into your mental, spiritual DNA over a tiny amount of elapsed time. Whereas cramming is basically taking quantum leaps in your understanding in what seems like an instant. So let's delve into the concept of standard position and the measurement of the trigonometric function cosine. Standard position and trigonometric functions. When an angle theta is in standard position, the cosine function of the angle theta is defined as. Definitely press pause if you need to collect and organize your thoughts and produce an answer, okay? I'll give you a moment to think. All right, so hopefully by now you are able to come up with an answer, and if not, that's completely fine. Let's try this out together. In the first cram session of the series, we established the concept of standard position for an angle theta. But just in case you forgot, an angle theta is in standard position when its vertex is located at the origin, its initial side ray is on the positive x-axis, and its terminal side ray terminates in quadrant 1, and this ray we'll call R for short. And note that this theta in standard position is an acute angle because it's bound by the quadrantal angles 0 degrees and 90 degrees. In case you forgot, quadrantal angles are angles whose terminal side ray terminate on either the x-axis or any of the y-axis in both the positive and negative directions, okay? But let's say, for our sake of determining the cosine function, that we have a point P. So P has coordinates x and y, and P is going to cut off this terminal side ray and make it a terminal side segment, okay? And again, for our purposes, point P has the extent of x and y, okay? So let's illustrate this. Give me like 2 seconds. All right, so, okay. The extent of P in the x direction is going to be x. So we're also going to allow that x point to cut off our terminals, our initial side ray of x, and make it a line segment, starting here, ending here rather. And let's say that the extent of the height resolution of our terminal side segment goes to the level of y, okay? So what we have now is the formation of a right triangle, which we're going to indicate like so. Okay, now this is great because we have our triangle, and we need triangles in order to determine any trigonometric function. We have a special right triangle here, and what we also need to establish is that r, the measurement of the terminal side segment, or the hypotenuse of this right triangle formation, can be found by squaring the x-coordinate, squaring the y-coordinate, adding them together, and then taking the square root. This is just a variation of the distance formula, okay? So you also see that no matter what the sign of the x and y coordinates are, the distance or the magnitude of terminal side segment hypotenuse r, I'm giving it all sorts of names, is always going to be positive, okay? Because you're squaring to eliminate any negatives, then you're taking the square root. So that's that. And now as for the cosine. Well, we know that in standard trigonometry, the cosine of any particular angle is going to be the adjacent side divided by the hypotenuse. So let's just illustrate that. So the cosine of theta is equivalent to the adjacent side, which here we're calling x, the x-coordinate. And notice that this x can be positive in quadrants 1 and 4, but negative in quadrants 2 and 3. Okay? And that has to be divided by our hypotenuse r, which will always be a positive value because it's actually a magnitude or distance. Okay, so this is our definition for basically the cosine of an angle theta in standard position. So that's our answer. As you can see, intellectual comprehension of this material was not difficult at all. All right, and I think we pretty much covered all the points that we needed to in order to properly understand this concept. So once you order the complete Cram session, you'll be able to answer a gamut of questions, the whole range of questions in Algebra 2, where trigonometry and geometry is also are also subtopics of Algebra 2. So thanks for tuning in. Good luck studying, and be sure to inbox me at memedicine@gmail.com to order the complete Algebra 2 Cram session.